Okay, this next set of problems is where we're writing the equation. Remember, when you're writing an equation of lines, you want to have a point and a slope. That's what you need, a point and a slope. And you want to use the point-slope formula to do that. Okay, so here, number 9 says it has a slope of -4/3. That was left off. And it goes through the point 0, 7. We have a slope, we have a point, so we can go to the point-slope form. So y minus 7 equals -4/3 times x minus 0. Distribute and solve for y. So -4/3 x plus 0, add 7, and y equals -4/3 x plus 7. This particular problem, you actually could have gone directly to the equation, because if you recognized that this was a special point, it's the actual y-intercept. You have the slope, you have the y-intercept, you can go directly to y equals mx plus b, and you get -4/3 x plus 7. Notice they're the same, and either way is perfectly valid. All right, with number 10, we have a slope, we have a point. This point is not the y-intercept, so you do indeed need to use the point-slope form. So y minus y1 equals m times x minus x1. So y minus -11 makes that plus 11. The slope is 8 times x minus 7. Distribute and solve for y. So 8x minus 56, subtract 11, and y equals 8x minus 67. And that would be the equation of the line that has a slope of 8 and goes through the point 7, -11. You'll notice with number 11 that we have 2 points and we don't have a slope. In order to write the equation of a line, you need a slope. So the first thing you have to use is the slope formula to find the slope. So remember that that was the difference in the y's over the difference in the x's. So that's going to be 7 minus 8 over -4 minus 5. And you get -1 over -9, or +1/9. So now we have a slope and you have 2 points. It doesn't matter which point you choose. I will choose the first point because they're both positive points there. So I'm going to use the point-slope form. Y minus 8 equals 1/9 times x minus 5. Distribute. Y minus 8 equals 1/9 x minus 5/9. Add 8 and simplify. That's 1/9 x plus 67/9. Okay, we're still trying to write the equation of the line. This time we have a point, but again we don't have a slope. But we want to actually find the slope of this line because we want the line that we're going to write to be parallel to it. So the first thing we have to do is solve this for y. So x minus 3y equals 15. When you solve for y, we'll subtract x. And then divide by -3. So y equals +1/3 x minus 5. So the slope of this line is 1/3. Remember, we want the slope parallel to that, and parallel lines have equal slopes. So in this one, I'm going to also use a slope of +1/3. And then I'm going to use the point -16/4. So y minus 4 equals 1/3 times x minus a minus is plus 16. Distribute and add 4. And y equals 1/3 x plus 28/3. Okay, another one where we're writing the equation of the line. This time again we have a point and we don't have a slope. We want the slope to be perpendicular to this line. So the first thing I have to do is find the slope of this line. So to do that, I'm going to divide everything by 5. So I get y equals 2/5 x minus 5. So the slope of this line is 2/5. Since I want my equation to be perpendicular to this line, I need to use the slope that is a negative reciprocal to 2/5, which means flip it and change the sign. So it would be negative 5/2. And now I'm going to use the point-slope formula with the point and the slope to find my equation. So y minus a minus 12 is y plus 12 equals negative 5/2 times x minus 10. Distribute. And subtract 12. And that's the equation of the line that goes through the point 10, negative 12, and is perpendicular to the given line. Okay, for 14, 15, and 16, we want to determine whether these are functions. For a mapping diagram, as in number 14, what we want to do is see if any of the x values, this would be the domain values, and those are the ones on the left, whether these repeat. And you'll see there's only one line coming from each value in the domain, so therefore this is indeed a function because the x values do not repeat. For equations, recall that x can have any variable on it, any exponent on it, so that would be a yes. However, the y cannot be squared, so that would be not a function.